Hello guys, welcome to our class for today. Um, this is Noble Mind Science Tutors Online and I remain Otobo Michael. For today we are going to be treating circular motion. So please, if you are not subscribed to this channel, please click on the subscribe button, click on the notification button so that whenever we upload a new video, YouTube will notify you. Also, you can reach us through the WhatsApp number that is showing on your screen. Please give us a thumbs up if you like what we are doing. So for this class, we'll be going straight to circular motion. So I will encourage you to get your writing material so that you can get settled for this class. Also, I also want you to give us your comments. You can place your comment on the comment section, and also invite your friends. Introduce this channel to your friends so that they can come and enjoy this lecture that you are also enjoying. So right away, we are going to our class for today, circular motion. Okay, so circular motion is the movement of an object in a circular path at constant speed around a fixed position. So that is what circular motion is. And for an object that is undergoing a circular motion, the speed remains constant while the direction changes along the circular path. Right? So since the direction of the body is changing and velocity has magnitude and direction, it means that the velocity of the body is also changing along the circular path and it is directed tangential to the circular path. Okay, so this is a brief definition of circular motion and this is what I just described now. Okay, this is an object that is undergoing a circular motion. You see that the velocity is directed at a tangent to the circular path while the acceleration is directed inward. Then this centrifugal force is directed inward too. The centrifugal force is directed outward. Centripetal force inward, centrifugal force outward. Okay, so this is what circular motion is. And I want you to take note of this, that when a stone tied to a string, which is wide in a circular path, is suddenly cut, the stone will fly off at a tangent to the circular path. So, and this is it. So if a stone is tied to this string and along the line the string cuts off, the stone will describe this path. It will move along this path at a tangent to the circular path. So take note of this statement, because sometimes in either JAM or WAEC, these questions comes in your objective. So take note of this. Is that okay? So this is just a brief description of what circular motion is all about, right? Okay, so we're going to talk about centripetal acceleration. Centripetal acceleration. So what is centripetal acceleration? The acceleration in a circular path is always directed inward toward the center of a circular path, and it is called centripetal acceleration. So centripetal acceleration is the acceleration that is directed towards the center of a circular path, and that was just discussed earlier. The acceleration that is directed inward toward the center is called centripetal path or centripetal acceleration. Centripetal acceleration. So on a daily basis or on your everyday experience, you see objects that undergo circular motion, like the ceiling fan, the blade of a ceiling fan, right? The blade of a ceiling fan. The motion of the blade of a ceiling fan is circular motion, and it rotates about the hub. Then a stone that is tied to a rope, which is weighed round, also undergoes a circular motion, right? Okay, then the planet too. If you study the solar system, you know that the planets, right, they move around the sun in a circular motion. Then a car that is turning through a curve, like this car that is turning through this curve, is describing a circular motion. Is that okay? So these are examples of circular motion. In your day-to-day activity or in your day-to-day activities, you come across different objects that also undergo circular motion, so that you can actually you can find that one out. That okay? So these are examples of circular motion, or objects that undergo circular motion. So we're going to talk about linear speed and angular velocity. Linear speed and angular velocity. So if you have an object that is describing a circle, okay, like this object moved from point P to point Q, the distance that the object covered is this S that is given here. Now, the angle that the object describes is known as the angular displacement. And then this is the radius from the center of the circular motion to the outside of the circle. This is the radius. Is that okay? The velocity is at a tangent to the circle. The velocity is at a tangent to the circle. So we will derive an equation of linear speed and angular velocity from this diagram that we have here. That okay? So angular velocity is defined as the angular displacement divided by the elapsed time. That is this angular displacement divided by the time that it takes to describe this angle is known as angular velocity. So we're going to derive that equation shortly. We'll derive that equation shortly. So if you have these parameters, that the displacement of the particle s from P to Q is given by s, and then the radius of the circle is given by r, then angular displacement measured in radians is given by theta. This theta is measured in radians in most cases, so take note of that. And then the time for the angular displacement is given by t. Then you can actually derive an equation that relates all these variables that you have here. You can derive an equation that, and these equations are what we are going to derive shortly. So if you look at that circular path that we described just now, we saw the radius of the circle, the distance covered, which is s, and then the angular displacement, or the angle that is described. Now if you check your geometry, you know that length of arc in radian is equals to the length of the arc, which is the distance that the object covered, distance PQ, is given by radius times theta in radians. Radius and theta in radius times theta. This theta is measured in radians, so that gives you the distance covered by that object. So, and that distance is equal to the length of arc PQ. Is equal to the length of arc PQ. So take note of this. You know that in your normal mathematics, length of arc is given by theta over 360 times pi radius. Right? Theta over 360 times 2 pi radius. That is in your normal mathematics. That is in mathematics. Okay, that is when theta is measured in degrees. If theta is measured in degrees, length of arc will be given to you, or it will be given by theta over 360 times 2 pi radius. But if theta is measured in radians, then your length of arc is radius times. So once you know the radius and you know the angular displacement in radians, you can actually calculate the length of arc, which is the distance described by that particle. Okay, so that is one equation that you need to take note of. You need to take note of this equation. Then from your normal linear acceleration, you know that speed or velocity is equal to displacement all over time taken. In linear acceleration, we've treated that already. So velocity is displacement over time. So this is your linear velocity. Now, how is this linear velocity? We'll now see how it is related to angular velocity as we progresses. Now, if linear velocity is equal to displacement over time taking, right? If it is displacement over time taking, then which means that v, which is the linear velocity, is equal to s over t. That is displacement, right, all over time taken. Now from this our first equation here, we are given that s, which is displacement, is equals to radius times angular displacement. So you can substitute that for this in this equation so that you have that linear velocity v equals to radius times angular displacement all over time taken. So you can see the relationship between v and the radius, the angular displacement, and the time taken. Is that okay? Now, angular displacement or angular velocity represented by this symbol is equals to angular displacement all over time taken. Angular velocity is equals to angular displacement over time taken. Linear velocity is equals to displacement all over time taken. Angular velocity is angular displacement all over time taken. So if you know this, you can write the equation as angular velocity is equals to angular displacement all over time taken. And this is measured in radians per second. This is the unit of measurement, radians per second, for angular velocity. It's measured in radians per second. Okay, so if you have this, you can actually make your angular displacement the subject of formula. And if you make it the subject formula, you are going to have this, that angular displacement is equals to angular velocity times time. Angular displacement is equals to angular velocity times time. So I want you to take note of this equation that are numbered here. This equation 1, this is for the displacement, equation 1. Equation 2 tells you that the linear velocity is equals to the radius times angular displacement all over time taken. Right? Take note of this equation and see. Then angular velocity is equals to angular displacement all over time taken. Angular displacement is the theta, is the angle that is from. This angle is measured in radians. Take note. Then all over time. And when you make the angular displacement your subject of formula, you have angular displacement is equals to angular velocity times time. Remember that even in your linear velocity, displacement is equals to velocity and time. So the same thing applies here too. Angular displacement is equals to angular velocity times time taken, right? Okay, and this is measured in radians. Angular displacement is measured in radians, while angular velocity is measured in radians per second. That's okay. So we'll look at the relationship between this linear speed and angular velocity. We've seen angular displacement. We have also seen linear velocity or linear speed, which is this. We have also seen angular velocity. So what's the relationship between linear speed and angular velocity? So that's what we're going to see. Okay, relationship between linear speed and angular velocity. We have said from our previous equation that our linear speed is equals to the displacement all over time, which is equals to radius times angular displacement all over time taken. That is what we got in equation 2 that we just described. And we also said that angular velocity is equals to displacement all over time, right? So if you substitute this into this part of this equation, you will have that this is equals to this radius that is here, radius times this. So which means that linear velocity is equals to radius times angular velocity. So this is the relationship between the linear velocity and angular velocity. Please take note of this. Take note of this, because depending on the equation that you are giving, if you are giving radius and angular velocity, you should be able to find your linear speed, right? You should be able to find your linear velocity. So the linear velocity is related to the angular velocity by this formula. Okay, it's related to linear velocity by this formula. Now, having known all this, what about the centripetal acceleration? Centripetal acceleration is given by centripetal acceleration A is given by v, which is linear velocity times angular velocity. Now, if you look at this equation that we had, if you look at this equation, A equals to RW, this is from this equation, we can actually substitute for V into this, we can substitute for V into this equation. We can substitute for V into this equation. So if you, in place of V, if you put RW, it will give you this. You will have this equation. So centripetal acceleration is equals to radius times the square of angular velocity. Right? Centripetal acceleration is equals to radius times the square of velocity. So if you substitute for V, you have this equation. Take note of this. Now, also from this particular equation, if you make your angular velocity the subject of this formula, you will have that angular velocity equals to V, linear velocity all over radius. So if you substitute this one now into this equation 2, you will have acceleration will be equals to radius times V square all over r square. Then when you do your, if you do your cancellation, you are going to have that centripetal acceleration is equals to V square all over r. So you need to take note of these equations, these formulas, because depending on the equation that you are given, you now know which of the formulas to use. So centripetal acceleration is also given to you to be V square, that is linear velocity square all over radius, or it is also given to you to be radius times angular velocity square. So depending on the equation that you are given, then you can use either this equation or this one to solve for centripetal acceleration. Is that okay? So I want you to also take note that for one complete circle, an object describes an angle that is 360 degrees, and 360 degrees equals to 2 pi radians, right? So these are information that you need to take note of when you are talking about circular motions. All these equations that we have discussed so far, they are all related to circular motions, and they are equations that you need if you have to solve any problem on circular motion. So please take note of them, and I want you to put them down in your notes. Remember that radius is measured in meters, velocity is in meter per second, and angular displacement is in radians, and then angular velocity is in radians per second. These are the units of measurement of these different variables that we just discussed. So please take note of all this. So right away, we need to solve some problems to drive home this one. So I want to solve a question now to see how we can apply these equations. Is that okay? So this is a sample question. This is a sample question that we need to solve. The question says that a particle moves in a circular orbit of radius 0.02 meters. If the speed of the particle is 0.8 meters per second, calculate the angular velocity of the particle. Alright, so you are giving, for this question now, you are giving that radius is given to you to be 0.02 meters. That is radius is given to you. Then you are giving the linear speed. The speed is given to you to be 0.88 meters per second. Now you are asked to find the angular velocity. This you don't know. So we just discussed an equation that relates all these variables, right? So you look at the equation to use. Okay, we said that linear speed is equals to what? Radius times angular velocity. So make angular velocity the subject of your formula. You will have that angular velocity is equals to what? Linear speed all over radius. So substitute your values. into this equation, you have 0.88 divided by your radius, which is 0.02. So by the time you work that out, you are going to have that 0.88 divided by 0.02 is equals to 44 radians per second. So this gives you your angular velocity of the particle. So it's quite simple. So please know how to apply these equations and then how to use them to solve different problems. All right. So these are test questions just to test your understanding of the topic that we just discussed. So the first question says that an object of mass 0.4 kg attached to the end of a string is whirled round in a horizontal cycle of radius 2.0 meters with a constant speed of 8 meters per second. Calculate the angular velocity of the object. This is more or less like what we just solved now. The second one is a stone tied to a string is made to revolve in a horizontal cycle of radius 4 meters with an angular speed of 2 radians per second. With what tangential velocity will the stone move off the circle if the string cuts? So please solve these problems. As I've always encouraged, you can solve them on a piece of paper, then post your answer on the WhatsApp number that is showing on your screen. That okay, I will see the way you solve it, then I will also make my comment. If your method is okay, then I will make my comment. That okay, so thank you for your time. This is where we're going to stop our class for now. So please, if you have not subscribed to the channel, please just subscribe, give us a like, give us a thumbs up, invite your friend to come and join this channel. This is physics class direct to your doorstep. So please, if you like what we are doing, give us a thumbs up. Also give your comments. You can reach us through the WhatsApp number that is showing on your screen. That okay, so until I see you next time, have a nice day. I'm going to see you in our next class. Thank you.